at this stage, we're ready to automate at least the traversing part of the list. So I got our previous program. I made basically a copy of it and gutted it, took all the code that we did before, and just kept a couple items. Made sure that I had a pointer head and a pointer list PTR, okay? And we know we're gonna assign this to the first node we ever create, and then thereafter to every node we create after that. We're gonna use the list PTR to actually do the data output. So the objective for this lesson is the data output within a loop, okay? So if that's the case, we're gonna keep the data entry we had here the same. And then for the next lesson, we're gonna automate this part. So we're gonna create a node, and then the second one, and then the third one. So we're gonna copy all of this, exactly the same code we had before, okay? And let's put it right here for data entry. So nothing really structural has changed here. So let me just compile this. Good. Now, the lesson is this data output. How do you output or traverse this list? Well, first of all, I want to assign list PTR to the actual list. And who represents this list better than head, who is actually pointing at the first element of the list? Perfect place. So you take list PTR and make it equal to head. Now you're pointing at the beginning of the list, since head will always point at the beginning of the list. List PTR is what I want to change as I iterate. So the next thing, since I have it, I might as well go ahead and print, and I'll tell you why if you don't do that. Print the head item and move the pointer within a loop, right? So, and while you're moving the pointer within the loop, print again. So the technique here is to go ahead and printf, and that would be %s /t and a $%.2f, just to get some sort of /n, a currency formatting. And then we have, now watch this, list PTR. Now we know it's pointing at the head right now, so you could say head if you want at this stage, or you could write list PTR. It wouldn't matter for this particular line of code. It will be the same. And it will give you the same result. List PTR, since they're both pointing at the same thing. And that would be balance. Okay, so that would print the first item. Now we're going to create a while loop. And notice what I'm going to say here. As long as list PTR next is not equal to null. As long as that's the case, we're good. Keep moving and traverse the list. Let me close the curly brace. The first thing I'm going to do is move the pointer to the next element. I have to. Let me just do this here. And just line up this one right here. And so, how do you do that? List PTR is going to be equal to list PTR pointing to next, the next element. Okay, well now we're ready to actually print, so I can copy this, the next element. So let's do that right here. And we're done as far as the data output. Okay, because at the end, what's going to happen, list PTR next is at null. That's great. Print the tail. You are at tail at this stage. And then you're going to come back to the while loop. Since you are at tail, you're no longer going to need to be in the loop again, because list PTR next is null. But you were at least able to print its content before you tested it again. Okay? All right, so that's a source of a lot of mistakes I see with some of my students. So let's go ahead, compile, and run this part. And let's start with Joe. 20 bucks. Jane owes me $45. And Jill owes me $100. And there you have it. Okay? And notice Jill comes out first because she's at the head of the list. The last item I entered is at the head of the list. Joe is the tail. Okay? Fantastic. All right, so the next video, what we're going to do is automate the data input in a loop that will allow us to increment, while we're in that loop, the size of this data structure. So it may have one item, it may have two items, it may have 0 items, okay, 100 items. And then the data output that we have here, we don't need to worry about it anymore. We're done. We need to worry about the data input because, as you can see, it'll be very tedious to sit here and create every object. And this is at compile time. We want to do this at runtime. Aha. So we're going to use new syntax to be able to create an object dynamically at runtime. Here, the code itself knows that you have CL1, CL2, CL3. We're cheating in a way. That's not reality. That's not how things work, right? So in reality, this is a fixed size list. And we want in the next video to be able to do what we call a dynamic list. And notice our output will adapt. That's not a problem. We've fixed that issue. So we need to rework this part, which is the data entry, where we dynamically allocate space and memory space for a new object. I will see you then.